Our universe might be really, really big, but infinite, or it might be infinity big. Both cases, says physicist Brian Greene, are possibilities, but if the latter is true, so is another posit. There are only so many ways matter can arrange itself within that infinite universe. Eventually, matter has to repeat itself and arrange itself in similar ways. So, if the universe is infinitely large, it is also home to infinity parallel universes. Does the sound confusing? Try this. Think of the universe like a deck of cards. Now, if you shuffle the decks, there's just so many orderings that can happen. Green says if you shuffle the decks enough times, the orders will have to repeat. Similarly, with an infinite universe and only a finite number of complexions of matter, the way in which matter arranges itself has to repeat. Green, the author of The Elegant Universe and the Fabric of the Cosmos, tackles the existence of multiple universes in his latest book, The Hidden Reality Parallel Universes and the Deep Laws of Cosmos. Recent discoveries in physics and astronomy, he says, point to the idea that our universe may be one of many universes populating a grander multiverse. You most cannot avoid having some version of multiverse in your studies if you push deeply enough in the mathematical descriptions of the physical universe. He says there are many of us thinking of one version of parallel universe theory or another. If it's all a lot of nonsense, then it's lot of wasted effort going into this far out of idea. But if this idea is correct, it is fantastic appealable in our understanding. So let's check another point: how quantum mechanics and general relativity play a part. Green thinks the key to understanding these multiverses comes from string theory, the area of physics he has studied for the past 25 years. In a nutshell, string theory attempts to reconcile a mathematical conflict between two already accepted ideas in physics, quantum mechanics and the theory of relativity. Einstein's theory of relativity does a fantastic job for explaining big things. Green says quantum mechanics is fantastic for the other end of the spectrum. For small things, the big problem is that each theory is greater for each realm. But when they confront each other, they are ferocious antagonists and the mathematics fall apart. String theory smooths out the mathematical inconsistencies that currently exist between quantum mechanics and the theory of relativity. It posits that the entire universe can be explained in terms of really, really small strings that vibrate in 10 or 11 dimensions, meaning dimensions we can't see if it exists. It could explain literally everything in the universe, from subatomic particles to the laws of speed and gravity. So, what does this have to do with the possibility that a multiverse exists? There are a couple of multiverses that come out of our study of string theory. Green says within string theory, the strings that we are talking about are not the only entities that this theory allows. It also allows objects that look like large flying carpets or membranes, which are two-dimensional surfaces. And what that means within string theory is that we may be living on one of those gigantic surfaces, and there can be other surfaces floating out there in space. The theory, he says, might be testable in the Large Hadron Collider at CERN, the European Organization for Nuclear Research. If we are living on one of these giant membranes, then the following can happen. When you sum particles together, which is what happens at the LHC. Some debris from those collisions can be ejected off our membrane and be ejected into the greater cosmos in which our membrane float. He says if that happens, that debris will take away some energy. So if we measure the amount of energy just before the protons collide and compare it with the amount of energy just after they collide, if they're a little less after and it less in just the little way, it would indicate that some had flown off, indicating that this membrane's picture is correct. Green explains that when he began studying string theory and parallel universe, it was not because he could one day measure energy at CERN or develop new mathematical equations. He simply liked the idea, he says, of studying something on such a large scale. We are trying to talk about not just the universe but perhaps other universes, but all within a logical framework that allows us to make some definitive statements. He says to me that's enormously exciting to step outside that every day and really look at the universe within these mathematical terms on its grandest scale. So guys, this is the short explains why parallel universe may exist. Hope you guys like this video. If you guys like this video, please don't forget to subscribe my channel and like the button and press the bell button for upcoming video. Till then, take care.